So in this session, we can see how to handle this Power Factory software when you are working on the new projects. So as I told earlier, to open the new file, you can click the file menu and you can create the new project from here. In case if you want to open the existing project available in the Power Factory, you have to go to the activate project menu and you can see the list of project available in the Power Factory database. So you can click the project and you can right click and you can select activate project so that the project in the Power Factory will get activated. So you can see that the single line diagram that you have created in this file will get appeared here. So while right clicking this, you can see that the graphical freeze mode is enabled here, which means if the graphical freeze mode is enabled, you cannot draw any additional new network in the SLD. So for this you have to disable the graphical freeze mode here from here. You can also disable the graphical freeze mode by right clicking this option directly, and so that you can see all the components available in the Power Factory will get enabled. So with this we will be seeing one by one like modeling of all the components available in the Power Factory. So coming to the major components that we are using for the analysis. So the first thing is grid. So this grid can be typically assigned as slack bus, which means reference bus, which will be providing the voltage and angle reference for the voltage levels. So at here you can see that my voltage is set to 1 per unit and the angle is at 0 degree. That's replicated in the simulation as well. The voltage is 1 per unit and the result is 110 kV. So if I want to do a case with 1.1 per unit of grid voltage, I can modify the voltage from here and I can rerun the load flow analysis. So in this case you can see that my grid voltage it got modified to 1.1 per unit. So this grid it will be providing the voltage and angle reference to the terminal buses. Typically the angle will be kept as 0 degree for the reference and the voltage set point it can be modified based on the requirement. For example, if you want to perform the case with the grid voltage of 1 per unit, you can set the voltage set point as 1 per unit here. And in case if you want to perform the simulation with the grid voltage of 1.1 per unit, you can modify the grid voltage to 1.1 per unit here. And coming to the transformer, the inputs required for the transformers or its type, where you have to define your MVA rating, your frequency, your HV voltage, LV voltage, your vector group, phase shift and short circuit impedance. And there are options where you can enable some parallel transformers. So for example, if there are two parallel transformers, instead of modeling it physically as a two separate transformers, you can multiply the number of transformers using this. And next, coming to the load modeling. So in this load modeling, we have to double click the load and you have to go to the load flow page and you can see the input parameters that have to be entered for the load. So for the load, there are two parameters are required. One is active power and its power factor. The input mode can also be switched to different modes by drop down option. So where you can see there are some different input modes where you can select the input as apparent power and the power factor, or current with active power, or it can be active power and the reactive power. So you can switch to any of the modes and you can input the parameters for this load. And if you want to model 110 kV transmission line or cable in this network, you can insert some new terminals here and you can select the component called line and you can click between the two bus bar so that the line will be connected between the two bus bar, And yes, you can define the line type, whether it's a cable or OHL. You can have to specifically define the cable or line parameters in this type drop down. And yes, here you have to update the length of the transmission line or cable. So in our case, I'm modeling the 30 kilometer cable, and I'm selecting the library available in the Power Factory. For this, I have to go to the line type, and I have to browse to the Dixalign library, and here equipment types, and from here I have to go to cable, IEC, and I have to choose the voltage, and conductor type it's copper. And yes, I can select the cable library which is available here. And for our project, I'm using the 630 square mm cable, and yes, and I'm rerunning the simulation. Yes, so here you can be able to see that the results are getting displayed, and all the three buses are energized. The network is now with grid, transformer, and load, and the transmission line. So in our case, if you want to add some additional components like capacitor bank or reactor or a three winding transformer, so all these components can be added from, added from here, and you can use it in your projects.